Problem number 2. At 298 Kelvin, the standard enthalpy change for this reaction here, right, we have hydrogen sulfide plus sulfur dioxide yields sulfur and water, is minus 145 kilojoules. 4 parts here. A. Predict the sign of the standard entropy change for the reaction and explain it. At 298 K, the forward reaction is spontaneous. What change, if any, would occur in the value of delta G naught as the temperature is increased? Explain your reasoning using thermodynamic principles. C. What change, if any, would occur in the value of the equilibrium constant? Explain your reasoning. D. The absolute temperature at which the forward reaction becomes non-spontaneous can be predicted. Write the equation that is used to make the prediction. Why does this equation predict only an approximate value for the temperature? Predict the sign of the standard entropy change. Well, we're going to predict that delta S naught is negative. This is because a high entropy mix of 3 molecules of gases forms a lower entropy mix of a solid and 2 molecules of gas. A reduction in the number of molecules of gas results in a reduction of entropy. At 298 Kelvin, the forward reaction is spontaneous. What change, if any, would occur in the value of delta G? Okay. The value of delta G naught would become less negative and eventually become positive as the temperature increases. Delta G naught, the Gibbs free energy equation here, equals delta H minus T delta S. And since delta S naught is negative, minus T delta S naught is positive. As T increases, so does the positive value of that term. The reaction becomes less spontaneous until it reaches equilibrium, and at still higher temperatures, non-spontaneous. What change, if any, would occur in the value of the equilibrium constant for the situation described in Part B? Well, let's see. When minus T delta S is less than 145 kilojoules, K equivalent, the equilibrium constant, will be greater than 1 because delta G naught less than 0 favors products. When minus T delta S is equal to 145 kilojoules, the equilibrium constant is 1 because the reaction is at equilibrium. And finally, when negative T delta S naught is greater than 145 kilojoules, and equilibrium constant is less than 1, but greater than 0 because delta G naught is greater than 0, so the reaction favors reactants. Part D, the absolute temperature at which the forward reaction becomes non-spontaneous can be predicted. Write the equation, and why does this equation predict only an approximate value for the temperature? Well, when delta G is equal to 0, then T equals delta H naught over delta S naught. This assumes that delta H and/or delta S do not change with temperature. This is not a perfect assumption, leading to errors in calculations.